combinations and bits and pieces type questions now at the end of the topic. This is an excellent thing. It's a question of spotting it rather than it being difficult, to be honest. So I've called it changes in distribution. So the question would start out in one distribution, and this one starts out with a straightforward normal distribution question. Jars of jam, they've got a mean weight of 305 grams, standard deviation of 3. If they're under 300 grams, that's probably what's written on the jar, then they are underweight. Find the probability that a jar is underweight. This is a standard normal distribution question, and I'll use my calculator and quickly find that the answer is it's about 5% of the time, 0.05. And there's no great prizes for knowing that. But then the question will change direction and it will say something like this. What is the likelihood that out of a batch of 10 jars, there are less than 5 that are underweight? Now, if we examine that line, I'm trying to highlight it there, this is binomial because it has a fixed number of trials, 10. It has two things that can happen. Either the jar is underweight or it isn't. We will assume independence and that there is a fixed probability. Now we've just calculated the fixed probability, and that's how the one question leads naturally into the other. So we've got in that statement all the ingredients of a binomial question. So we've used the normal distribution to generate a probability, and then we transfer to the binomial. Okay, so we've got the probability of the weight, and that is being less than 300 grams, or being underweight is that. So we've got the number of trials now is 10. X equals 2 or less, so 0 underweight, 1 underweight, or 2 underweight. All of those three satisfy less than 3. The probability of success, well, which is really failure, probability of being underweight is 0.05. And so we go, and again, that's a calculated job, and we've got 0.09885. So it's, in fact, if those are the probabilities, we wouldn't expect that more than 2 would be underweight. It's highly unlikely. And if we compare that with the expected value, then the expected number that are underweight is 0.05 times 10. We only actually expect that out of 10, half of one on average would be underweight. So if we have 1 in every 2 batches, so therefore we're not surprised by the relatively high probability here. But the trick is start with one distribution, usually to generate a probability that allows us to move into a different type of distribution, often a binomial, but not always.